Hello and welcome to Machine Arena. Today we'll explore the fascinating world of railway and road construction. From powerful machines to skilled workers, each step reveals the precision, dedication, and innovation shaping modern transportation. Let's begin. The scene opens with a team of workers carefully guiding massive pieces of rail into place. These steel sections are heavy and unwieldy, far too large to be handled by hand. That is why modern railway construction relies on powerful cranes and lifting equipment. The machines hoist each section from delivery wagons and slowly swing them into the prepared track bed. Every movement must be controlled with precision. The workers on the ground communicate constantly, using hand signals and radios to guide the operators. Inch by inch, the rails are lowered, and as the steel meets the ballast, adjustments are made to ensure exact positioning. Even a small error at this stage could cause problems once trains begin to run over the track. The coordination between man and machine is striking. The crane provides the strength, but it is human skill that ensures accuracy. Teams work side by side, checking alignments, measuring distances, and making sure the rails fit seamlessly into the existing system. This process reflects the discipline and rhythm of the railway industry. Each person knows their role, and together they form a synchronized effort. Once the rails are in place, workers secure them to sleepers and adjust the ballast beneath. The ballast is carefully compacted so that the track sits firmly, resisting the vibrations of passing trains. Specialized tamping tools may be used to lock the stone tightly under each tie, ensuring long-term stability. This installation is not just about laying steel, it is about building reliability. A properly placed rail section can remain in service for decades, carrying countless trains safely across the network. The meticulous teamwork on display here demonstrates how progress in the railway depends on both advanced machinery and the dedication of skilled workers. Every completed section adds to the larger system, gradually expanding the railway's capacity. Watching this process, we see not only the construction of infrastructure, but also the building of connections, links that will serve communities, economies, and travelers for generations. In this part of the journey, we focus on one of the most vital steps in creating a strong and continuous railway: welding the rails together. Here, two workers dressed in full protective gear carefully prepare the joint between two massive steel sections. Their task is to transform two separate pieces of rail into a single, seamless line that can carry trains for decades. The process begins with a mold clamped securely around the small gap between the rails. Once in place, the workers ignite a special mixture inside a crucible above the mold. The reaction burns intensely, reaching temperatures of thousands of degrees. Molten steel flows downward, filling the gap completely and bonding the two rail ends together. While the metal is still glowing red, the workers remain close, monitoring the reaction with calm precision. Every step follows strict technical standards, ensuring safety and consistency. The heat is immense, but their protective suits, gloves, and visors shield them as they guide the process. As the weld cools and solidifies, the temporary mold is removed. What remains is a rough joint, stronger than any bolt or fastening could achieve. But the work is not finished yet. The excess material must be carefully trimmed and ground away. Using specialized grinders, the surface is shaped until it matches the surrounding rail perfectly. The result is a smooth, even track that allows train wheels to glide without interruption. There are no gaps, no jolts, only a continuous stretch of steel designed to withstand tremendous pressure. This method highlights the balance of strength and craftsmanship in railway construction. Behind every seamless ride lies the patient work of skilled hands, carefully following established procedures to ensure safety, durability, and comfort for every journey ahead. Railway maintenance requires powerful tools, and hydraulic wrenches are among the most reliable. These machines are designed to tighten or loosen the massive bolts that secure rails and fastenings. Unlike hand tools, hydraulic wrenches apply consistent, controlled torque, ensuring each connection is uniform and safe. On a railway line, hundreds of bolts may need adjusting in a single shift. Hydraulic systems make this work faster and more precise, reducing strain on workers while guaranteeing accuracy. Properly fastened rails are essential for track stability, preventing movement under the weight of trains. It's a perfect example of how even small details, like a tightened bolt, play a big role in the overall safety of a railway. As our journey continues, we now arrive at a modern racing circuit under construction, where teams of skilled workers and specialized machines are working together to create the smooth, asphalt surface required for high-speed racing. Unlike ordinary road paving, building a racetrack demands an extraordinary level of precision. Every curve, every straightaway, and every banking angle must be carefully prepared to ensure safety, consistency, and performance once the track is in use. The scene opens with a wide view of the site, where numerous heavy machines operate simultaneously in perfect synchronization. Massive dump trucks deliver loads of asphalt mix, which is then transferred into large paving machines. These machines steadily spread the material across the track's surface with remarkable consistency. Behind them, teams of rollers, ranging from heavy steel drum compactors to lighter rubber tire machines, follow closely, pressing the asphalt down to achieve the perfect density and smoothness. Workers in protective gear move carefully around the machines, checking measurements, guiding operators, and ensuring that every section of the track meets exact specifications. Each person has a distinct role, yet together they form a seamless rhythm of collaboration. Some are responsible for surveying and measuring, ensuring that the thickness of the asphalt is even. Others focus on temperature control, making sure the material is spread and compacted at the right moment before it cools. Every adjustment is deliberate, as even the smallest inconsistency could affect how racing cars perform on the circuit. We can see that the process is not rushed, but it is highly efficient. The coordination between men and machines allows the work to proceed smoothly while saving valuable time. The operators handle their equipment with care and precision, almost as if they are conducting an orchestra of steel giants across the construction site. From the vantage point of the camera, the complexity of the task becomes clear. Multiple layers of asphalt must be applied, compacted, and refined before the track reaches the required standard. The sheer scale of machinery moving in harmony gives the impression of a grand industrial ballet, machines laying the foundation while people guide every move with patience and expertise. By the end of the process, the site is transformed. What was once uneven ground is now a smooth black surface, strong enough to support heavy use for years to come. It is a clear reminder of how modern construction combines advanced machinery, human skill, and precise coordination to achieve lasting results. Now we move deep underground, where an entirely different challenge awaits the construction of a subway railway line, Unlike track work on the surface, where large cranes and massive equipment can assist, much of the work here must be performed in confined spaces, relying heavily on skilled hands and careful planning. Inside the tunnel, the environment is tight, dark, and demanding. Workers wearing protective helmets and headlamps carefully install concrete supports along the sides of the track bed. Each support column must be set into position with great accuracy, as even the smallest misalignment could affect the stability of the rails above. We see men tightening bolts, securing steel frames, and checking every joint to ensure it meets the strictest safety standards. The rails themselves are maneuvered into place with smaller lifting devices and sheer manpower. Unlike on the surface, where cranes move entire panels at once, here the rails must be positioned section by section. Teams work together to lift, align, and secure each piece onto its base. Levels and measuring tools are used constantly, as the geometry of an underground rail system requires millimeter precision. Bridge-like structures are erected within the tunnel to support cables, signaling systems, and utilities. Each installation involves careful calculation. Workers climb, measure, adjust, and fasten components until everything fits perfectly. The pace may appear slow, but the precision is deliberate. Every screw tightened and every nut fastened contributes to a system designed to last for decades. Meanwhile, from the surface above, concrete is delivered down into the tunnel through large pipes. The material flows steadily, filling molds and forming the foundation around the rail structures. Underground crews spread and shape the concrete quickly before it hardens, smoothing surfaces and preparing the ground for the next phase. As soon as one task is finished, another begins: drilling, anchoring, or laying additional reinforcement. What is remarkable is the sheer number of processes happening at once in such a confined space. Some workers focus on rail alignment, others handle structural supports, while another team manages the constant flow of materials. Communication and timing are everything, ensuring that no step interferes with the next. This short glimpse reveals how complex subway construction truly is. Each rail, each bolt, and each concrete pour represents hours of labor, coordination, and technical expertise. Unlike the wide-open surface, underground railways demand patience, adaptability, and craftsmanship. Watching the process unfold, we gain new appreciation for the countless efforts hidden beneath the streets of our cities, building the lifelines that will carry millions of passengers safely every day. Here we see the paving of a wide and lengthy roadway, an operation that requires both heavy machinery and careful coordination. As the sequence begins, several large rollers can be seen moving steadily back and forth, pressing the freshly laid surface into a smooth, even layer. But before these rollers can do their work, a series of other machines must first prepare the asphalt and spread it across the road. The process starts with a massive transport truck filled with tons of hot asphalt mixture. This truck arrives on schedule and positions itself to unload its cargo. The asphalt is then poured into the hopper of a specialized paving machine. This machine acts as both a feeder and a distributor, keeping the asphalt hot and workable while preparing it for application. Next, a paving vehicle moves forward at a steady pace, spreading the mixture evenly across the roadbed. Its wide screed smooths the material as it is laid down, ensuring the correct thickness and coverage. Operators inside the cab carefully monitor every detail, adjusting speed and distribution to keep the layer consistent. Once the surface has been placed, the rollers follow immediately behind. These machines, weighing many tons, apply pressure to the asphalt, compacting it firmly into place. Multiple rollers often work side by side, overlapping paths to ensure that no gaps or soft spots remain. The rolling process eliminates air pockets, strengthens the surface, and creates the smooth finish that drivers depend on. From a distance, the operation looks like an assembly line stretched across the length of the road. Each vehicle has a specific role, and timing is critical. If the asphalt cools before compaction, the surface will weaken. That is why every step, from unloading the truck to the final pass of the roller, must be completed with precision and efficiency. This coordinated process is repeated again and again until the entire roadway is complete. The result is a strong, durable surface, built to withstand constant traffic, weather, and time. It is a vivid example of how teamwork between people and machines creates the infrastructure that keeps our world moving. In this stage, we witness the creation of roadside barriers, an essential part of modern highway and railway safety. These barriers are designed to guide traffic, protect vehicles, and provide a strong shield against accidents or shifting soil along the road. The process begins with concrete mixing. Large machines prepare the exact blend of cement, sand, water, and aggregate, ensuring the right consistency for durability and strength. Once mixed, the fresh concrete is transported through a conveyor system, moving steadily toward the placement site. This continuous flow reduces delays and keeps the material workable. Here, we see a remarkable innovation: specialized barrier-forming machines. These powerful vehicles shape the wet concrete directly as it is poured, creating uniform walls in one smooth pass. The molds inside the machine give the barrier its precise height, width, and curvature. The result is a seamless structure without the need to lift and position heavy precast sections. Workers accompany the machine, monitoring the alignment, checking measurements, and ensuring that every section sets correctly. Their role is vital. Machines provide the force, but human oversight guarantees accuracy and quality. Together, they form a synchronized team, balancing mechanical power with craftsmanship. As the freshly formed barrier cures, it hardens into a permanent structure that will stand for decades. This efficient combination of mixing, molding, and human skill shows how modern construction methods save time while delivering safety and reliability on every mile of roadway. Here we observe the careful process of repairing damaged sections of roadway, where small depressions and potholes threaten both safety and comfort. Even a minor flaw in the pavement can grow into a serious hazard if left untreated, so timely maintenance is essential. Before any work begins, warning signs and barriers are set up around the site. These signals protect both the crew and passing vehicles, ensuring that the repair can be carried out without interruption. Safety is always the first priority. Once the area is secured, workers begin by cleaning the damaged spot, removing loose debris and dust. Then, a layer of special repair compound is spread evenly across the depression. This material is designed to bond with the existing asphalt. To activate it, workers apply heat, softening the mixture so it fuses tightly with the surface. The process does not stop with a single layer. After the first application, another layer is spread, followed again by heating. This repeated cycle builds strength and ensures the repair is solid from the base up. Finally, a specialized top compound is applied, sealing the surface completely. Once heated and leveled, The patch blends almost seamlessly into the surrounding pavement. The result is a smooth, durable repair that restores the road to full strength in a very short time. Unlike traditional patching, this thermoplastic method resists cracking, water damage, and temperature changes. It is an efficient solution that keeps roads safer, reduces long-term costs, and demonstrates how modern techniques make infrastructure maintenance faster and more reliable. In this segment, we witness a modern construction method in the railway industry, the installation of prefabricated track slabs. Unlike traditional techniques that require multiple complex steps on site, this approach relies on components that are manufactured and quality checked in advance, ensuring speed, precision, and consistency. First, the heavy track slabs and concrete bases are transported to the worksite using specialized trucks. Large cranes and lifting systems are then deployed to carefully lower each massive slab into place. Workers coordinate closely with the machinery, constantly measuring and adjusting to guarantee that every section is perfectly aligned and positioned with millimeter accuracy. Once the slabs are laid down, the next step is securing them. Teams of workers tighten bolts, inspect each joint, and weld the necessary connections to create a continuous and seamless track. Laser measuring tools are also employed, offering precise calibration and minimizing any chance of misalignment. After the track sections are connected, the foundation beneath is reinforced with concrete or crushed stone, further enhancing the durability and load-bearing capacity of the railway line. This ensures that the track can withstand heavy trains and decades of use without compromise. The prefabricated track system offers significant advantages. It reduces construction time, minimizes errors, and provides a safer working environment for the crews. At the same time, it reflects the progress of railway engineering, combining skilled human effort with advanced technology to build infrastructure that is both reliable and efficient. This method stands as a clear example of how modern innovation is transforming railway construction, making the entire process faster, more precise, and ultimately more sustainable. As we approach the conclusion of this journey, the camera introduces us to a truly remarkable sight, a massive, bright yellow machine, towering in both scale and capability. At first glance, it may seem like just another piece of heavy construction equipment, but in reality, this machine represents the pinnacle of modern railway construction technology. It is a fully integrated, multifunctional powerhouse, designed to handle nearly every aspect of building and maintaining railway lines with precision, efficiency, and strength. The process begins with transportation. Traditionally, dozens of trucks, cranes, and separate crews would be required to move and position the enormous concrete blocks and steel components needed to assemble a railway. But with this machine, the task is centralized. Using its powerful gripping arms and conveyor systems, it lifts heavy concrete sleepers, guiding them smoothly along its structure before placing them onto the track bed. Each movement is controlled with millimeter accuracy, ensuring that every sleeper is perfectly aligned and evenly spaced, forming the essential foundation of the rail line. Once the sleepers are in place, the machine seamlessly transitions to the next stage, distributing ballast stones. These crushed rocks are vital to stabilizing the track, absorbing vibrations, and supporting the weight of passing trains. Conveyor belts and controlled hoppers allow for even distribution, ensuring the layer is spread uniformly beneath and around the sleepers. Workers nearby oversee the process, making minor adjustments, but the bulk of the heavy lifting and precision is entirely handled by the machine itself. The next step is rail installation. Long steel rails, transported in advance, are lifted into position by the same machine. With specialized clamps, it carefully lowers each rail onto the sleepers. What once required cranes, multiple workers, and hours of delicate adjustments is now performed smoothly in one continuous operation. The rails are aligned, fitted, and temporarily fastened, ready for welding and securing. The machine even assists in this alignment process, using built-in sensors and laser-guided systems to guarantee straightness and correct curvature, a necessity for the safe and efficient movement of trains. But the machine does not stop there. Integrated hydraulic systems allow it to press and secure the rails firmly onto the sleepers, applying consistent force across the track. As it moves forward, it also performs checks on geometry and load distribution, ensuring that the newly built section can withstand the immense stresses of future train traffic. Every detail, from spacing and height to the balance of forces, is calculated and optimized in real time. This automation does not eliminate the human role, but enhances it. Engineers and operators monitor the system from control cabins, while teams of workers walk alongside, verifying results, tightening bolts, and ensuring safety. The partnership between human skill and machine power demonstrates how far construction technology has advanced. Today, all of these tasks are integrated into a single unit. This reduces cost, speeds up construction, minimizes logistical challenges, and perhaps most importantly, increases worker safety by keeping heavy manual tasks under the control of mechanized systems. Looking at this machine in action, one cannot help but admire the ingenuity of modern engineering. It is not merely a tool, but a symbol of human creativity and innovation. By combining multiple roles into one, it represents the optimization of time, labor, and resources. Each function flows into the next, like a perfectly choreographed performance, turning what was once a laborious and fragmented process into a streamlined operation. As the massive yellow giant moves steadily down the construction site, laying the groundwork for future trains, it serves as a reminder of how far we have come. From hand tools and manual labor to advanced multifunctional machines, railway construction has evolved into a field where technology and human expertise work hand in hand. This machine is a testament to that progress, an embodiment of precision, strength, and intelligence in one. Thank you for joining us on this journey with Machine Arena. We've witnessed the skill of workers and the power of modern machines shaping railway and road construction. If you enjoyed this exploration, please like, share, and subscribe for more incredible stories.